Okay, this is lecture number 7. And hello friends, welcome to the IAS Coder. And we had discussed earlier topics in first 6 lectures. Basically, we have covered many topics of the Indian geography, starting from the monsoon and forest soils. Okay, and we have almost finished the first chapter in the physiography, and we are just left with some miscellaneous topics. Okay, and then we will start with the next topic. That is again a very big topic, that is drainage system of India. So in miscellaneous topics that we will discuss, number one is the cyclones, tropical cyclones. Although the tropical cyclones we will discuss in the climatology in very detail, both temperate as well as tropical cyclones. But here the brief discussion about the cyclones in both the oceans, that is Bay of Bengal as well as the Arabian Sea, right? And their spatial distribution. This is the first topic that we will discuss in the remaining miscellaneous topics, and the second one is the your western disturbances, right? Western disturbances and their changing nature because of climate change, and impact of climate change on the western disturbances. Impact of climate change on western disturbances. So these two topics, and then we will start with the drainage of India, right? So let us start with, without any delay, the first topic, that is the tropical cyclones. First of all, it is very important to understand that tropical cyclones are the circulatory system which develops in the tropical region, right? In the warm waters where the water temperature extend from 25 to 28 degrees centigrade. So this temperature is generally is the time period of, or fall in the time period of October, September, October period. So this is the prime period of the formation of tropical cyclones in Indian Ocean. The second one is the formation of tropical cyclones need the circulatory forces, and these circulatory forces are provided by Coriolis force. Coriolis force, right? And Coriolis force is near zero at the equators, right? This force is zero at equators. That means the tropical cyclones will never cross the equator. That means, let us say this is 0 degree and a tropical cyclone is formed here. It will not jump over to this point, because at this point the Coriolis force is 0, and they need circulatory force, which is Coriolis force. So that means the tropical cyclone will never or not form in this band around the tropics. You can say that 5 degree north, 5 degrees south. Okay, they will form beyond this band. Okay, so this is point to be remembered. The third point, that with regard to tropical cyclones, their properties or their condition for formation is that they require the latent heat of evaporation. Latent heat of evaporation for their formation. Right. Now this latent heat of evaporation can only be obtained when there is water present there, right? Now that means the tropical cyclones will always form above the oceans. right? And then they will travel landwards. Now, when they fall on the land, the heat of evaporation does not exist because there is no water beneath the tropical cyclone. That means on the land, the tropical cyclone starts dissipating, right? So, this is the third point that you can remember about the formation. But the topic of concern in Indian geography is not this. This is the topic of concern of the climatology. Here we will discuss the distribution of tropical cyclone in Indian Ocean. Right. Basically, in case of the distribution of cyclones, first we will do the temporal distribution. Temporal distribution. In temporal distribution, there are two seasons that we will identify. One is the primary peak and another is the secondary peak. Right. Another is the secondary peak. Primary peak, this is the season of retreating monsoon. This is the season of retreating monsoon. We had already discussed about retreating monsoons. If you have not watched that video, you go back and watch that video. I think it is in first class. So in the retreating monsoon, November month, okay, for example, this time the Amphan cyclone fall in the retreating monsoon months. Amphan cyclone. The secondary peak is in April May month. Is in April and May month. This is the season of pre-monsoon showers. Right. So, but what is the commonality in between in both of these two primary peaks and the secondary peak season is that ITCZ lies over North Indian Ocean. Right. This is the commonality in between both the peaks. Right. This is the temporal distribution. Moving on to the next distribution that we will do is the spatial distribution. Now, in case of spatial distribution, the cyclones occur in both the Arabian Sea as well as Bay of Bengal, but their frequency is more in Bay of Bengal. See, this is the Arabian Sea, right? This is Arabian Sea. This is Bay of Bengal, right? This was the path of the Amphan cyclone. Okay, this was the path of Nisagra cyclone. Similarly, this was the path of Oki cyclone. Now you can see the cyclones are present in both the oceans, but their intensity and their frequency is more in the Bay of Bengal region. Now we will see the reasons that why the cyclones are less frequent in Arabian Sea and more frequent in Bay of Bengal. So why? Cyclones are more frequent in Bay of Bengal, are more frequent and intense in Bay of Bengal, right? So this is the main concern here. Now, the reasons for this are mainly two, three reasons. Number one is that Bay of Bengal receives warm waters from the Western Pacific, right? Number two is the Bay of Bengal receives typhoons from Pacific Ocean. Pacific Ocean. These are the regions here. Now see both the regions here. You look, see this thing. This is the shape of Indian subcontinent here. Okay, something like that. This is the Malaysia here, and this is Sumatra, right? This is Java, right? This place is called the Isthmus of Kara. Isthmus of Kara, right? Now what happens that here lies the tropics, the 0 degree equator, right? Now what happens that here the north equatorial current, they brings the warm water from this area, from the Pacific. Okay, now because of this warm water, the suitable conditions develop in this area for the cyclones, right? The next point is, this is the Pacific Ocean here, this is Pacific, right? Now in the Pacific, the cyclones which form are called the typhoon. Now these typhoons are brought in the western side or in the Bay of Bengal side by these currents, okay, by these trade winds. Okay, this is also a trade wind belt, right? This is also the trade wind belt. Now this trade wind belt brings the Pacific Ocean cyclones which are called typhoons towards the Bay of Bengal, and these typhoons jumps this small patch of land which is isthmus, right? And they reaches in the Bay of Bengal, where they are further intensified because the prevailing suitable conditions present in Bay of Bengal area, right? So these two are the main reasons for formation of more number of cyclones. But why this area affected more? Because the coastline is stable for causing the more damage, right? This coastline in the eastern side, east coastline, number one, it is the low lying area, right? Very low lying area. Number two, it is sedimentary formation, right? Unlike the west coast, which is basaltic granite and gneiss formation. Number three, large fishing villages are present. Large fishing villages are present. So because of these regions, this hazard of the cyclones becomes the disaster many a times in the east coast region. So this is the reason why Bay of Bengal has more cyclones. But in case of, if you see in the Arabian Sea, so this is the Arabian Sea here, this is Arabian Sea, right? In Arabian Sea, what is there? The waters of Arabian Sea, of this area of Arabian Sea, have the cold currents. And which is the main cold current in the Arabian Sea? The Somali current. Okay, Somali current. And this current reduces the temperature of Arabian Sea. Along with this, the mighty Indus River falls. Indus River. It also plays a role in reducing the water of the North Arabian Sea. right? So all these factors are responsible for not formation of the large number of cyclones in the Arabian Sea, right? So this is the first topic that we wanted to discuss in miscellaneous part, right? Moving on to the second part, second topic number 2 is the your western disturbances and the climate change influence. Western disturbances, although we touched in brief the western disturbances in class number 1 or 2, but we will discuss in more detail with the western disturbances here in this thing. So western disturbances are nothing but they are temperate cyclones. They are temperate cyclones, right? And these temperate cyclones form in Mediterranean basin. In this region they form, and from there they are brought to the Asian subcontinent by subtropical westerly jet streams. Subtropical westerly jet stream. But the main point is that when they form in the Mediterranean area, these cyclones, temperate cyclones, are strong. But by the time they reach the subcontinent, the Asian subcontinent, Indian subcontinent, they become weak. But that does not mean that they do not have influence in the Indian subcontinent. They have the many influence. Number one is the winter rains. They bring the winter rains in India. Winter rains, okay, in Himalayan region. And this winter rain is beneficial for rabi crops. And these western disturbances sometimes brings down the temperature by 10 degrees centigrade below the normal, okay, when they arrive, right? So these are the few properties of the western disturbances. Along with this, now let us see that how they arrive and how they travel in India. This is the Himalayan region, right? Something like that. So western disturbances travel along with the subtropical westerly jet stream, right? This jet stream brings here, right? And this is the region of mountains here, right? This is the Himalayan region. But when this STWJ arrives here with the clouds, with the temperate cyclones, okay, it set their moisture in this region, okay? So this region will experiences the cloud and the rainfall, right? So this is the how this STWJ arrives and set its moisture in the Himalayan region, Himalayan belt, okay. Now the distribution of the western this thing STWJ, we have seen the spatial distribution. So if you see the distribution in case of this, in this thing, they are mainly mainly main effect is in the main in the western Himalayas and eastern Himalayas, western Himalayas and eastern Himalayas, right? But in case of the temporal distribution, if you see the temporal distribution, the main frequency of western disturbances start from November onwards, and from November to February there are variable number of western disturbances which are recorded. For example, in January, if you see in January 2019, January plus February 2018, 2018, we witnessed two disturbances, right? While in the same months 2019, India witnessed six disturbances, right? Six disturbances. So you cannot say that their number is fixed, but the western disturbances they even arrive in April and May month, and their frequency varies, right? So this is the distribution of the western disturbances. Sorry. So one thing is this about the temporal distribution. But when you see the impact of climate change on the western disturbances, impact of climate change on western disturbances. Number one is there definitely there is a reduction in the rainfall days and the snowfall days. There is reduction on snowfall days. Okay. The frequency of western disturbances, frequency of western disturbances has changed, right? For example, as we told that in 2018, in the January-February month, there were only two western disturbances. But in 2019, in January-February month, there were six western disturbances. So their frequency has changed quite a lot, the western disturbances. So these influence of the climate change on the western disturbances can be mentioned. Okay. So this was the second topic. Now we have completed the physiography of India. Physiography of India. Right. The few topics if are left I will see, and then we will discuss in the separate class those topics, but more or less we have completed it. Now we will be moving on to the next topic, that is the drainage of India. It is again a very big topic, drainage system of India. So first of all you must know about the drainage system. It is nothing but the origin of a river and further its development. Origin of river and its development. Okay, and this is all that we will do in this chapter, right? So without delay, moving on to the drainage of India, this that let us start this thing. And first of all, what we will do is the divide the drainage system of India in two parts. Okay, in two parts. Number one, we will do is the Himalayan drainage. Right, and then we will do the Peninsula drainage. Right. So in Himalayan drainage and the Peninsula drainage, we will first try to discover their origin, that how both the system originated. Such big systems developed in India. Okay, and there are different theories with regard to the development of both the Himalayan drainage as well as the Peninsula drainage. Okay, but Himalayan drainage is more broad and more deeper. So for Himalayan drainage, the first theory that was given was the Indo-Burma and the Shivalik River hypothesis. Indo-Burma and the Shivalik River hypothesis. Now what this hypothesis says, this says that earlier there were two mighty rivers which were western flowing, right? There were two mighty rivers which were flowing in the west direction in this manner. Okay, the northwest flowing river was the Tibetan river. This was Tibetan river, and the southwest flowing river was the Shivalik river, right? And this both the rivers had their tributaries like this. These both the rivers had their own tributaries. Now, as per this theory, Indo-Burma and Shivalik river, these these tributaries started the headward erosion. These tributaries started headward erosion, right? And because of this headward erosion, there was dismemberment of these both the rivers. So dismemberment of the Tibetan river led to the formation of dismemberment of Tibetan river led to the formation of Proto-Indus and the Proto-Indus, Proto-Brahmaputra, and Proto-Satluj river, right? And similarly, the dismemberment of the Shivalik river led to the formation of dismemberment of Shivalik river led to formation of Proto-Ganga and Proto-Yamuna, Proto-Ganga and Proto-Yamuna river, right? And later, these rivers started flowing in the eastward direction after formation of the Malda Gap, right? Now you must know what is Malda Gap. Suppose that this is the Rajmahal Hills. These are Rajmahal Hills, and this is Meghalayan Plateau here. This is Meghalayan Plateau. So during the Pleistocene and the Tertiary period, this this gap between the Meghalayan Plateau and the Rajmahal Hills got sagged. So this sagged part is called the Malda Gap. Now this Malda Gap was filled by the sediments which were brought by the Ganga and the Brahmaputra river. Okay, and this is the currently accepted theory as well. But this one. But these theories, that is Indo-Burma and the Tibetan river hypothesis, this is not the accepted theory, right? This has been contradicted, and the multiple river origin theory. Which theory? Multiple river origin theory. We will do this in detail. Multiple river origin theory. Right, this theory is accepted today for the formation of the Himalayan drainage, and it was given by the Inayat Ahmed, right? According to Inayat Ahmed, Himalayan drainage evolved in many phases. Okay, so we will do first the phase number 1, that is formation of the Trans Himalayas. The first one is the formation of Trans Himalayas. So during the Trans-Himalayan formation, what happened? That the rivers. So this was the Eurasian plate. This was the Eurasian plate, and the Indian plate was going beneath this Eurasian plate, right? Indian plate was going beneath this Eurasian plate. This is Indian plate, and here formed the Himalayas. Now the fast flowing streams started descending from these Himalayas into what? Tethys Sea. So these streams descended into Tethys Sea, right? And these descending streams were called as the Proto-Indus, Proto-Satluj, Proto-Kali, Proto-Brahmaputra, Proto-Kali, Proto-Brahmaputra, right? So this was the first phase when these proto rivers formed, when they started descending from these Himalayan state. But here was the Tethys Sea. Okay, so they were descending in the Tethys Sea. Basically, Tethys Sea has not completely disappeared by this phase. Now moving on to the second phase, phase number 2. What happened during this phase? The formation of Tethys Himalayas and Great Himalayas. And Great Himalayas. Now during this stage, the Tethys Sea has disappeared, right? And the already existing proto rivers, they become antecedent rivers, right? The rivers which were descending, rivers cut across the Himalayas, these great Himalayas and Tethys Himalayas, and formed deep gorges deep gorges. And these rivers were called as antecedent rivers. Antecedent rivers, for example, Satluj River, Indus River, Brahmaputra River, Kali River. So they were antecedent river. And these antecedent rivers were joined by consequent streams. Now, which were these consequent streams? Example: Ganga, Yamuna. Right. So these were the consequent streams which were following the slope, general slope. Right. So this was the phase number 2. Moving on to the phase number 3, formation of lesser Himalayas or middle Himalayas. Phase number 3, formation of lesser Himalayas. Now during this phase, the course of rivers changed. The rivers become east-west. Rivers became east-west. During the earlier stage, that means during this Tethys Sea and Great Himalayan stage, these rivers formed the lakes, right? They were mostly draining in the lake, right? Which was the relic Tethys Sea, we can say, but not relic Tethys Sea, mostly the lakes which had become the east-west, right? Now in this stage, these rivers became east-west, further cutting across the lesser Himalayas, right? And new consequent rivers were formed. New consequent rivers were formed, right? And these consequent rivers were, the examples were Ravi, Bias, Jhelum. These were the new consequent rivers which formed during this stage. Now, finally, what happened in the tertiary period? Garo Malda Gap formed. Garo Malda Gap formed, and this Garo Malda Gap provided the destination for east-west flowing rivers. Provided perfect destination for east-west flowing rivers, right? And the river started flowing towards this Garo Malda Gap, both Ganga as well as Brahmaputra. And this Garo Malda Gap was filled with sediments, okay, which today are the Sundarban mangroves, right? So this was how the Himalayan drainage formed in detail, right? Moving on to the next part, that is the peninsular drainage. How the peninsular drainage formed. Peninsular drainage got formed. Although there is no particular theory about this drainage, but it is largely accepted that there was something plateau of this shape, right, in the Mesozoic time. This was a shape of plateau, and the rivers were flowing in both the direction, right? As this Indian plateau, peninsular plateau, was moving towards the eastward direction, northeast direction, there led to the fracture in this plateau, and these fractures finally got developed into this shape in the tertiary period and the quaternary period, right? And this shape, this part is today referred to as the Western Ghats, right? And this part went under the ocean, now the Arabian Ocean. So the streams which descend from this side are swift, fast flowing streams, very short course, but the streams which flow in this side, they have long course and flow through the narrow valleys like Godavari and Krishna. So there are no particular theories, but this is the procedure that may be how the peninsular drainage developed. But let us now discuss. Now we have developed the theories of both the peninsular as well as the Himalayan drainage. Now, briefly, what is the difference between both the drainage? Himalayan rivers and the peninsular rivers. Number one, Himalayan rivers, they are fed by glaciers, right? Glaciers fed river, right? Peninsular rivers, they are the monsoon fed river, right? These rivers, Himalayan rivers, they flow around the year, right? What we will say is, so the Himalayan rivers are the perennial rivers. Okay, around the year they flow. While the peninsular rivers have the monsoon peaks, so they are called ephemeral rivers. Right. The Himalayan rivers flow over the sedimentary geography or sedimentary topography. sedimentary geology. While the peninsular rivers flow over the basaltic geology. The Himalayan rivers, they have the deep valleys, deep valleys, while the peninsular rivers have narrow valleys. Right. The Himalayan rivers, they are long, big, mighty rivers. They are small peninsular rivers. The Himalayan rivers, another factor, they are young. They come out of the young fold mountains. Young fold mountains. Right. Rivers flow through this. They flow on the old topography. Right. And there are many other differences which can be written. For example, the Himalayan rivers, they form big deltas, while the peninsular rivers, they form the small deltas. They form small deltas. Right. So many differences between Himalayan river system and the peninsular river system can be written here. Right. So this was this topic. Moving on to in the drainage system, the next concept that we must know. This was the again a concept that we did, and the next concept number 2 in this thing, in the drainage that we must know, is the river regime. Now, what is river regime? It is nothing but the flow of water in the river across the seasons. Okay, that we will measure through the river regime. Now, river regime depends upon many factors. For example, it depends upon the precipitation, rainfall. It depends upon the evapotranspiration. Okay, evaporation from the trees. It depends upon the vegetation. Right. It depends upon the human interference, like dam buildings, and finally it depends upon the prevailing climate plus climate change. Right. So these are the factors which affect the water flow across the seasons in a river valley. So upon on the basis of these factors, now we will read or study the river regime in both the Himalayan as well as the peninsular river systems. Right. And we will see the difference how their river regime vary. Now first of all, the river regime of the Himalayan river system. Yes, river regime of Himalayan river systems. Right. See, we know the Himalayan rivers are perennial rivers. Okay, they flow across the seasons. Reason is very simple, because of they are glacier fed. Now the Himalayan river regimes, if you read in two parts, that is in the upper reaches, see in the upper reaches, the river regime of the Himalayan rivers is this something like this. This is flow here, and this is the months here. Now see, the flow starts increasing during the February month. Okay, and it starts decreasing September October month, post September. Okay, October November month. Now this is the peak monsoon period. This is peak monsoon period. Although monsoon in the upper reaches does not have much effect, but you must also remember that this is the period of the June July. right? Now when you see the lower reaches in the Himalayan rivers, lower reaches, in the lower reaches also the river regime is something like this, same shape, right? Okay, these are the monsoon months, and the river regime, the flow starts increasing in the same uh, February March month, and starts decreasing in the October November month when the rainfall retreats. Now when you see in the upper reaches, in the upper reaches in the Himalayan river, in this period June July, there is maximum glacier melt, but the glacial melt starts from the February month. Okay, and here is the maximum glacial month. But this peak monsoon, we say that this is because of peak monsoon is not a correct reason, because in the upper Himalayas the effect of, in this upper Himalaya region, the effect of monsoons is very less. Okay, effect of monsoon is less because the most of the region is in the rain shadow belt, rain shadow belt, because of the Himalayas. So effect of the monsoon is not very much, but effect of monsoon is more here. Okay. Another difference in these two reaches, upper reach and lower reach, or in both this graph, is that the flow level in the upper reaches is less. So this flow is less in upper reaches, and this flow is more in the higher reaches. This flow is more in in the lower reaches. Why? Because in the lower reaches there are more tributaries joining the river, more tributaries. Okay, join the river. While in the upper reaches there are less number of tributaries, less number of tributaries. So the flow level is also low, plus the region is more glacial melt, less peak monsoon, while in the lower reaches the flow level is more because of the number of tributaries, plus the region for this peak in the June July month is the monsoon instead of the more glacial melt. So this is the difference in the river regime in the upper reaches and the lower reaches in the Himalayan rivers. Now moving on to the next, that is the river regime in the peninsular rivers. River regime in peninsular rivers. In peninsular rivers, first of all, we must know that they are ephemeral rivers, as we said. Okay, the water is not flowing continuously throughout the year because they are mostly the monsoon driven rivers. So, in case of peninsular rivers, the water flow varies something like that. So, this is the river regime chart of the peninsular rivers. This is the peak monsoon month. Okay, June, July. This is the pre showers, pre monsoon showers. Okay, and one peak you can also make in this part because of retreating monsoons. One peak you can also make here. This is because of retreating monsoons. And this is the November December month, right? And the water starts increasing in the March May month, right? So this is the river regime of the peninsular rivers. Next we will move on to the, now we are studying the river regimes. We will see the impact of climate change on the river regime, right? So the next concept is the impact of climate change on the river regime. climate change on river regime. The first impact is of the climate change that we see is the temperature increase. So because of temperature increase, there will be the greater evapotranspiration. There will be greater evapotranspiration. Evapotranspiration. Plus, along with the great temperature increase, the climate change has brought another change, that is the decreased rainfall, overall decreased rainfall, right? And this decreased rainfall will also be having the impact on the river regime. Now what we will see is that, so let us once see third impact also, the increased glacial melt. Now because of increased glacial melt, initially the water in the river increase will increase. Initially you will see that water in the river increases. So this is the, let us say this is the river regime, right? Initially the river regime, mm, the waters may increase because of the glacial melt, but after some times, when there will permanent receding in the glacier, the river regime will be on the decreasing territory, some in this territory, right? Similarly, in case of the decreased rainfall and the temperature, river regime will also be something look like something like that, right? So this is the cumulative impact of the temperature increase, decreased rainfall, and increased glacial melt. And this all three happens because of the climate change, and this is the impact on the river regime. Now the next factor is the devegetation, right? So because of devegetation, what will happen, there will be decrease in infiltration of water, plus decreased rainfall because of devegetation. So all these factors will negatively affect the river regime, right? So this is the another effect that we can mention. Similarly, the third effect, but it is third is not more related to the climate change but more of the anthropogenic change, that is the dam building. So the building of the dams and reservoirs will also be having the negative effect on the river regime, right? So this is about the river regime, right, and the effect of the climate change on the river regime. So what we have discussed till now in the drainage system, that the formation and origin of the rivers and origin of rivers, both peninsular as well as the Himalayan rivers, right? The second that we saw, that was the difference between the Himalayan drainage and the peninsular drainage. Difference between Himalayan drainage and peninsular drainage. And the third that we saw was the river regimes for both peninsular as well as the Himalayan river regimes, right? The fourth point that we saw was the impact of climate change on the river regimes. Climate change and river regime, climate change and river regime, right? So these four topics we have done in the drainage system. Now we will do the next topic, that is the in detail. We will start with the individual drainage system, right? Now we are starting with the individual drainage system, and in this we will first cover the Indus drainage system. Indus drainage. After Indus we will do the Ganga drainage, and after Ganga drainage we will do the Brahmaputra and other drainages. Okay. Okay, so let us start with these drainage systems in the next class, and we will discuss in bit detail every drainage system, whether it is Indus drainage system, Ganga drainage, Brahmaputra, Yamuna drainage. All the river drainage systems will be discussed in complete detail, right? So we will discuss these topics in the next class. So this was the last of this class, so we'll meet in the next class. So do subscribe the channel, okay, and like this video and share this channel with your friends, right? So we'll meet in the next class. So thank you.